On this example now, we're going to sketch the graph, but as you can see, we're going to have two vertical asymptotes. So we need to factor this. X minus 2 cannot be factored, but the denominator can. So we are going to look for those two numbers that will give multiply into minus 3. So it looks like we're going to need a minus 3 and a 1. If you multiply minus 3 by 1, you get a minus 3. And if you add them, you get a minus 2. So those are our factors. And we're going to use them to find the vertical asymptotes. One vertical asymptote is going to be x is equal to 3. And the other one is x is equal to minus 1. So we already have the vertical asymptotes just like that. And because we didn't have any factors that repeat in the numerator and in the denominator, we don't have any holes. So we can forget about holes and just continue with the process. The x-intercepts come from the numerator, so we're going to have x is equal to 2, and we're going to write it as a coordinate as 2 comma 0. Once we have our x-intercept, let's find our horizontal asymptote. Remember, the numerator is a degree 1 and the denominator is a degree 2. So the obvious winner is the denominator. That means that we're gonna usually have a greater number down in the denominator. So the denominator is gonna overpower the numerator, and that's gonna tend to 0. So the horizontal asymptote is gonna be y equals 0. The y-intercept, we need to just evaluate the function with 0. Usually it is better if you do it on the original. So 0 minus 2 divided by, or at least that's what I like to do. And you're gonna get 2/3. Minus divided by minus, negative by negative, you get positive. So the y-intercept is 0 comma 2/3. And the domain of the function is, it goes from minus infinity to minus 1, from minus 1 to 3, and from 3 to infinity. So later on, we're going to find the extra points, the behavior near the asymptotes. But for now, let's just use what we have to get the skeleton of or the guidelines to sketch our graph. So this is going to be 1 to 3. So the vertical asymptote is going to end up around here. The other vertical asymptote is here. Then we have the horizontal exactly over the x-axis. So here. I'm going to keep going. Then we have the y-intercept. I'm going to use a different color. The y-intercept is at 0 comma 2/3, so just below the 1, because 1 is 3/3. So over there, we have an x-intercept at 2 comma 0, so 1, 2 over here. So we have enough points in between the two vertical asymptotes. Let's find a couple of points, or at least a point on the to the right and to the left on the sides. So what about using f of minus 2 close to the asymptote? So f of minus 2, we're going to have, let's use it on the factor version of the function. So it's going to be minus 2, then minus 2 divided by minus 2 minus 3, multiplying minus 2 plus 1. So this is a minus 4. And down here, we're going to have a minus 5. And that minus 5 is going to multiply a minus 1. So we're going to get a -4 dividing a +5. So that's the position, or the coordinate is going to be -2 comma -4/5. So close enough to the unit, because the unit would be 5/5. So we're going to go to -1 -2, and it's going to be just below the 1, because, sorry, it is negative, so it is going to be down here, just above the -1, because -5/5 would have been -1. So we're a bit short, but this is the coordinate -2 comma -4/5. Let's find a coordinate on the other side of the asymptote. So what about using, what's a close value? 4. So we're going to use f of 4, and we're going to do the same thing. 4 minus 2 divided by 4 minus 3. And we're going to multiply 4 plus 1. That's going to be 2 dividing, this is a 1, and this is a 5. So we're going to get 2/5. So the coordinate is 4 comma 2/5. Now that we have that, that's going to be closer to 0 than to 1. So we're going to have a coordinate that's 4 comma and around there. That's our coordinate, 4 comma 2/5. So we're going to have it real close to 0. And now let's find the behavior near the asymptote. So those were our extra points. So I'm going to write them over here just to remember them. 4/5. And the other point is 4 comma 2/5. So now let's deal with the behavior near the asymptotes. And that means that we're going to use numbers that are really close to our asymptotes. So this asymptote over here, the first one is x is equal to -1. And this one is x is equal to 3. So let's pick a value that's really close to this asymptote, but on both sides. So I'm going to use, if that's -1, I'm going to use -1.1, minus 0.9. On this side, I'm going to use 2.9 and 3.1. So I'm going to use all of those values, and I'm not going to focus that much on the actual value, but on the sign that we are going to get. And we're going to substitute that on the factor version of our function. So let's start with the first one. Now we're not looking for points, just the behavior. So 1.1, we're going to have -1.1 minus 2 divided by -1.1 minus 3 times -1.1 plus 1. So let's now only focus on the signs. So this is going to be negative. I'm doing negative, and then I'm subtracting 2. So it'll end up as negative. Then down here, I also have a negative number, and this one will also be negative. So this is negative multiplied by a negative number, that's positive, and negative divided by positive stays as negative. So that means that this graph, and it makes sense with the coordinate we found, is going to be negative, and the graph is going to be approach going down. It's going to go down in this direction. Now let's find the behavior of the other point. So I'm going to get rid of this, and I'm going to find the following value. So we're going to use this with f of -0.9. So we're going to get -0.9 and we're going to subtract 2. Then we're going to divide it by minus 0.9. We're going to subtract 3, and we're going to multiply by minus 0.9, and we're going to add a 1. So this is going to be a negative number. This is also going to be a negative number, but this is going to be positive. So negative divided by negative times positive, still a negative, and negative divided by negative, that's positive. So that means that we're going to have a positive behavior, meaning that it's going to approach the vertical asymptote going up. If we keep using this process, you're going to find that f of 2.9 is going to give you a negative value, and f of 3.1 is going to give you a positive value. So this is going to be positive, and the graph is going to go up. And over here, this is going to be negative if you work out the math, and it's going to go down. So we're going to use that information to sketch our graph. We're going to go from the known coordinate, and we're going to approach the vertical asymptote going in this direction, and we're going to also approach the horizontal asymptote. Then from the given coordinate, the coordinate that we know, we're going to approach the asymptote in the way that we were told by the sign. We're going to connect the dots, and there we're going to approach the vertical asymptote going down. And this one, going from the coordinate, we're going to approach the vertical asymptote and the horizontal asymptote. So that's a rough sketch, but it gives you the idea.